Hello and welcome to Chapter 11, More on Experiments, Confounding and Obscuring Variables. It should sound a little challenging right off the bat. Let's remind ourselves of what landscape we're playing in. Starting in Chapter 10, we started talking about experiments, and I kind of want us to remind us of the basic features that an experiment has. A good experiment allows us to make causal statements of relationship between an independent variable and the dependent variable in the study. And there's these three features. Covariance, that is, we see a change in one variable and it's associated with a change in the other variable. Any number of ways of measuring this, but the simple fact is an association is seen. Temporal precedence, we can tell that the independent variable occurred before the dependent variable was measured. And internal validity, we can rule out alternative explanations for the relationship that we see between the independent variable and the dependent variable. That's really where a great deal of the energy is spent in trying to develop procedures to get a handle on internal validity. Because as we're going to study in this chapter, there are numerous threats to internal validity, things that undermine our ability to say there's a causal relationship. We want to try to rule them out. Covariance and temporal precedence, those are fairly easy to establish and deal with. They're not really the big deals. They're logically important, but they aren't the hard stuff. The hard stuff is in issues of internal validity. So to remind us of two key characteristics about experiments and how we get internal validity. One is that we have to have a comparison condition in the study. And the other one is we have random assignment of participants to the conditions. Now these two things are going to be have been the focus of what we've been doing. We talked a little bit about comparison conditions in Chapter 10. Random assignment was a large focus of Chapter 10. Threats to internal validity are things that could be going on in a study that might provide an alternative explanation for the observed association between the variables. And this is very important that it is the observed association can be alternatively explained. Issues that might be threats to internal validity, if you don't see something going on there's no difference to try to explain, there's no association that you're trying to explain, then these issues really don't matter. You've got other problems you got to deal with. Random assignment and design choices and comparison conditions are used to deal with the various threats that we know exist for internal validity. These have all been derived from years and years of logical analysis of experimental methodologies. Now, Chapter 10, three threats to internal validity were managed. The selection effect. We deal with that by random assignment, with whether or not we get different kinds of persons in one condition versus another condition. By randomly assigning them, we handle it. Then we're going to speak kind of a special version of selection effect in a little bit. Design confounds, they're dealt with by ensuring that differences of nuisance variables we don't want them to systematically vary with the manipulations. And so we look for the various kinds of things that might be that kind of issue, like different colors of the rooms or different lighting levels or different noise levels, or the book has a great example on the different size bowl used to serve the pasta might change how attractive it looks, these kinds of things. Order effects, they're dealt with by use of careful design choices, counterbalancing or independent groups designs. These kinds of things can help us deal with the fact that order effects may be a big issue and have to be managed. We'll talk about them in a little bit, also in a different context. There are other threats to internal validity that random assignment simply can't solve. But the use of a comparison group, as long as we have other appropriate design characteristics, it can solve it. A threat to internal validity, to remind you, can only be an issue for a study if the following two things are true. At least one condition of the study was affected more by the issue than another condition, and the threat provides an alternative explanation for the actually observed results. You can't speculate, well, this might have been going on, therefore you might have the results. No. You can't say that something might have been going on therefore it might have been going on. No, you have to say this alternative explanation might have been going on, and that explains why we have the results we've observed. That's the key thing right there. And then for it to maintain even after we've created multiple conditions, it has to be something that affects one condition more than another. And we'll touch on that again later because it will become more apparent when we start talking more about what are the specific threats to internal validity. Now, we could just collect data, and your book gives several great examples of just collecting data on page 308 and 309. Even if we do a before and after intervention collection of data, a pre-test, post-test, one-group design, as your book terms it, that's not enough to show that an intervention has had an effect. You have to go further. You have to get a control or comparison group to know if the intervention was the reason things appeared to change. And that's because just collecting the data in a pre and post fashion before and after an intervention or manipulation doesn't tell you what people would have done if there had not been a manipulation in place. So the comparison group's purpose is to provide that control, the ability to say, well, this is what they would have done if I hadn't done that to them, if they hadn't received that treatment, if they hadn't been involved in that manipulation. These are simple designs. These simple pre-post one-group designs are simple, but they suffer from 6 possible threats to internal validity. And all these can be eliminated by the use of the comparison or control group. And all these threats can only matter, again, if they have a different effect for one group compared to another, even after you do set control groups in. Maturation, history, regression to the mean, attrition, testing, and instrumentation. I'll briefly touch on these, and we're going to go into detail on each of them. Maturation, that's the fact that over time, participants change. History, while being in a study, outside events may occur that could change how you respond to what's going on in the study. Regression to the mean is a measurement issue. Sometimes when we measure people, they appear to be exceptionally high or exceptionally low, and it's somewhat due to just the random luck of how they were scored, not really measuring their true value on the testing instrument. Attrition recognizes that sometimes people leave a study. Testing is about issues of people being tested and retested in a study and then becoming used to it. This is something we've alluded to in order effects earlier. Instrumentation is about the fact that we use sometimes actual mechanical or electrical devices, but also we have people that do observations, and they may be responsible for some issues in the study. Maturations are changes that happen simply because it is natural for participants to change over time. Children get older and they're going to learn more words, they're going to grow taller, they're going to get bigger and stronger, faster, they're going to know greater levels of complexity about the world, they're going to change in their cognitive complexity and how well they process information about the world. And we're not just talking about children. Older persons also go through maturation where they have some improvements and also some declinations in their abilities and skills. And so all of these things are related to maturation. And that is why this is usually discussed in the context of long-term studies in which a child or older person has developmental issues that are at the forefront. That's why we have the name maturation. It kind of captures that notion. But even over a really short time frame, this kind of effect can happen, such as how people act in a brand new environment compared to even a few minutes later. You might imagine that you do a study of children and their behavior, and they enter a room, and you're wondering if the color of the walls of the room, blue versus red, has an effect upon whether they're going to act kind of, in that, 4 or 5 year old kid crazy kind of way, or if they're going to settle down over a certain amount of time. They'll settle over some time, but you want to see if they settle, at a different rate if they have blue walls in the room. And When you first enter a space, this is true for all of us, we kind of take it in and look around. But for a kid, it's even more interesting. They see all the new toys, they see all the new stuff, new furniture, new space, new little places to hide and play, and they're all over the place. They're just having a blast. Usually, most kids are that way, and so and then 5 minutes later or 10 minutes later, they've kind of gotten accustomed to it. They figured out what toys they like to play with, and they've kind of settled down into their routine. Well, that change is kind of a maturation of comfort in the environment, a habituation characteristic, and they're not really well. It's not really due to the fact that they actually were responding to the color of the walls. And if you have a comparison group, you can make a judgment then about whether the color of the walls changed. We'll touch on that again later. History. History are changes that happen because of outside events that change how the participants respond to the study. Usually these are in the context of longer term studies, but it can matter in short term studies as well. And history and maturation are easily confused, but they're distinguished by the source of the influence. The influence for history is from outside the participant, an external event that has an effect on the participant that might be measured in your study. While maturation is a natural process from within the participant, it is simply how they're going to change and grow over time based upon being a human or animal that you're observing. How do we prevent history and maturation effects? Both of these are handled by use of a comparison group. Any effects that are due to maturation and history should affect the comparison group and the manipulated group equally. So whatever difference we might see between the comparison group and the manipulated group on the dependent variable after anything that might have gone on must be due to the manipulation, because the comparison group certainly was affected by history or maturation effects to the same degree, more or less, as the manipulated group. That's the assumption, and it's a pretty reasonable assumption. Now, regression to the mean is a relatively complex issue, so I want you to really follow along with me here. It's a measurement issue that makes it appear that people have changed due to the treatment or manipulation. It comes from the fact that extreme scores are likely to have a bit of random error that is making them be extreme. On the subsequent measurement that you do of the person after the first measure, remember we're kind of imagining that we're in this pre-test, post-test kind of measurement situation, that large error that you saw before the treatment or manipulation occurred is not likely to be repeated the second time you do the measurement. And so if they are appearing to be particularly high score or particularly low score, and it's due really to a great influence of random error, and it's not repeated, then it can look like your intervention had an effect when really all the person is doing is regressing to the score you should have gotten the first time you measured them. It's not actually anything happening, it just looks like it. And because many of our interventions are applied to persons who are scoring relatively extremely high or relatively extremely low on some scale that we've devised, this becomes a real risk. So it can threaten our validity because we cannot know for sure that our manipulation is what caused our differences in the dependent variable. Let's look at this in more detail by getting some numbers out. I know you're suddenly going, wow, math, Bernhard, get out of here. Yeah, chill, relax. I'm not going to ask you to do math. This is just to give you some sense of what we're talking about here. Whenever we measure someone, we're going to generate a score. When we use a measurement scale of some kind, we're going to generate a score. And what we imagine, based upon what's called classical testing theory, and this is something you'll learn a lot more about if you were to take tested measurements, is that there's some true value inside that person you're trying to extract, that you're trying to get at, something that you're trying to measure about them. And in that score you actually do observe is the true value, but it also is higher or lower based upon the contribution of random error. It is either a little high or a little low. It could be a lot high or a lot low. So let's imagine we've measured people on a scale that measures fear. And we see a range of scores from 5 up to 25, a variety of scores. Now those scores at the lower end, the 5, 6, 7, 8, 9, those they're more likely to have a large negative random error component. It's not guaranteed that they all have a large negative random error component. It's just they're more likely to have that component. That's how they ended up there. Some of them could be true scores. That is, that person that measured a 7 could really have a 7. They had no error in their measurement. And the 8 could maybe only have 1 point in measurement. But more likely than middle scores, the extremely low and the extremely high scores have a contribution from random error. The high scores similarly are more likely to have a large positive random error component, which increases them from their true scores. Now, if we imagine we're doing a study on fear, we are imagining that we're probably doing a study on the persons that have the highest amount of fear, the high scoring persons. And so we're going to not be people are not going to be showing up for treatment if they don't have much fear. They're going to be showing up for treatment if they have a lot of fear. And so they're going to be scoring high on our pre-test fear measurement. And so the pre-treatment average, the pre-test average is, well, in this case, 20. Okay, I've got these 5 people and they measure a 20. And then we put them through treatment, and then they come out, and we see the 20 went down to 25. Woohoo, looks good. The 22 went down to 19. That's some improvement. And the 20 went down to 15, and the 18 went down to 17, and the 15 went up to 16. For a post average of 17.4, that looks like there was some improvement. And we're very proud of ourselves, right? But this is a classic one-group pre-test, post-test design. And what we may be suffering from here is regression to the mean. That may explain what we're seeing happen here. The error there may be some error that made the person score 25, that their natural score really is a 20. They just happen to score 25 on this test. And so, the 20 person they should score maybe 17 on the test, and the second testing they scored 15 because they had some negative error component come in that time. You never know. Random error is random error. And so you don't know how it's affecting things, but high scores are more likely to have been affected by high positive error, and low scores are more likely to have been affected by low negative error. So we don't know. We don't know if our treatment really caused an effect. We need a comparison group. To do that, let's imagine that we've got twice as many people. And we have a distribution of scores that looks like this, a little bit more filled out than we had before, but ranging from 15 to 25, the same range we had before. And so we're going to deal with this threat by having 2 groups. And we're going to ensure the comparison group is similar by use of random assignment or a matched groups procedure, as we were talking about in Chapter 10. The pre-treatment average will end up being 20 for both of these groups after I'm finished showing you this. Let's suppose the 15 person gets assigned to the treatment group, and therefore the 16 gets assigned to the no treatment group if this was matched pairs. And the 18 person is assigned to the no treatment group, and that means the other 18 person is assigned to the treatment group, and the 20 persons are split into the 2 groups, and the 21 and 22 are split, and the 25s are split, and it's randomly done. Okay? And we end up with a 20 average for both of these conditions, the treatment condition and the no treatment condition. And then they go through treatment. And we have exactly the same outcome we did before. The 25 goes down to the 20, the 22 to 19, the 20 to 15, the 18 to 17, the 15 to 16. And the no treatment group has this happen. They come in at 18.6. Now, I'm not doing statistical analysis on this, but if we were to just take these numbers at face value, post-treatment, receiving treatment, 17.4, lower on the fear scale than those not receiving treatment, 18.6. And therefore, we might be able to make a reasonable conjecture that our treatment has a beneficial effect over and beyond the regression to the mean concern that we have. I hope that's clear to you, but if it's not, I really encourage you to come by and talk with me in my office on this, because this is a really important concept, and it is not an easy concept to get. Your book also has some different ways of looking at this issue in it. Attrition is an issue that can affect our internal validity. Attrition, sometimes called mortality, is when participants do not complete the study. Participants drop out after starting the study. It can threaten internal validity if their pretest scores are particularly high or low. Their loss in the post-test scores can make it look like a change happened due to the manipulation, when really all you did was just not get their score in the second time. Good news about attrition is it's very easy to handle this. Just remove their data from the pretest, and anyone who drops out of the study at any point in the study, you just remove their data throughout the study. It can be a little disconcerting. You don't like doing it, and there can be some other issues that can come about because of that. But it's basically the simpler thing to do. There are some other solutions your book offers as well. Testing has been discussed before, actually, as part of Chapter 10. Persons can improve or decrease performance due to practice or fatigue while doing a procedure. And Chapter 10 proposed using counterbalancing, and it's a very useful procedure for dealing with these kinds of effects. But for some studies, especially treatment interventions for various illnesses and psychological issues, counterbalancing is really not possible. And so you've got to come up with another solution. You want to use possibly different testing forms. Or you can eliminate the pretest, or change the measurement system can help. And let me describe a little bit what I mean by each of these. Different testing forms means that maybe I have two different versions of the Beck's depression inventory, and I give that to persons on pretest, and I use the A form there, and I use the B form when they are in the post-test condition, post-treatment condition. And because I might be concerned that people respond differently to forms A and B, I can have half my participants get form B first, and those half get form A the second time. They are known to be equivalent, but I still want to be careful in my design. And so using of different testing forms. I can even use a completely different test, but that gets a little bit more difficult to interpret. I can also eliminate the pretest. I just don't bother. I'm going to trust random assignment completely. It's a little risky, but it's certainly an option that's available to you if you don't have the ability to do effective pretesting anyway. You can also change the measurement system. If you change the measurement system to be more observational and less based upon forms of various kinds, then the persons are really not involved in any kind of practice or fatigue kind of issue. They're not actually doing testing, so to speak. They're simply being observed. And especially if you do the observation using videotape and such so that you can look at it later, then even your observers don't get into an issue of where they're getting fatigued, which is actually an instrumentation problem. But basically, they're not going to be a problem either. And so that's a way to help also, is to change how you're measuring it so it's one that does not tend to make persons grow more comfortable or less comfortable with what's going on. Instrumentation, it sounds kind of esoteric because we don't use much in the way of devices to do recordings in psychology. At least that's the way most students especially think. We actually use a lot more electronic and mechanical measurement systems than you might imagine. We do use research observers a lot. And one of the things that can happen is those research observers can have a change in their calibration. Just like a piece of equipment can change its calibration, so can an observer. If you have a scale at home that you stand on every morning, you may be appearing to be gaining weight. Or it could be that the scale's calibration is slowly drifting off. You might want to check it and make sure that it really is accurately measuring. Now, it can look like change happened because of the research observers changing their calibration, changing how they're observing things. But really, it's your observers becoming habituated to what they're seeing. Your book gives great examples in reference to its 3 examples of badly done studies, where over time you're watching people and you simply don't see the aggression that you formerly marked as very severe as being severe later, simply because you've grown accustomed to it. You are no longer as sensitive to what you were seeing as you were before. Now, to prevent these kinds of threats, you can eliminate the pretest. That's one way to do it, but that's not your best option usually. You can update training of observers to ensure that they stay properly calibrated. This is what you do, and in fact, this is often done. When I did a study of observing of political yard signs amongst my participants, I trained them, and then I checked their procedures afterwards by using an independent observer as a way of making sure they were calibrated on their measurements for real in the study. You can also use a comparison condition, but it's not really as big a deal. Uh, what the real issue here is that you have something that's in the control of the experimenter, and you allowed it to influence results when what you really should have been doing is preventing it by making sure people were properly trained and monitoring how they might be drifting in a way that is not representing the actual behaviors that they're observing. Instrumentation and testing also can be difficult to tell apart from each other. But remember, again, as before, it's a source. Where's the source of these two things? Instrumentation source is the measurement system. It's coming from the measurement system changing. And testing is coming from the participant changing how they respond to a measurement system. And so keeping in mind that it's either the measurement system changing itself or the participant changing in some way will help you keep these two separate from each other. So when is something a threat? None of these issues are threats to internal validity as long as the researcher takes them into account in their procedures, as long as they do their job, which is tough. Sometimes you have to make sacrifices and leave something in a bad form simply because you can't fix everything sometimes. On the other hand, though, all of these issues can be a threat to internal validity if there's reason to think that the issue happened in one condition and not the other. I want us to imagine that we have a sleep lab that is doing studies on how well people sleep at night. Maybe we have all kinds of things that we can measure. Maybe we have systems that measure how much people toss and turn while they're sleeping, and so we have a sensor pad that's underneath the mattress that measures their tossing and turning. And we can imagine all kinds of things that are part of a sleep lab. You can actually connect electrodes to their head, measure their REM status, and all these kinds of things. Now, history can be a factor. Let's imagine that this lab is a two-story building, an upper floor and a lower floor, and we're measuring how much people toss and turn. We have very good instruments that we know they're calibrated well. We know they're in good shape. We've treated everybody exactly the same going into the upper level and the lower level. And with one level, they're getting an intervention that has them do a meditation before they go to sleep, and the other one, we're asking them to do some reading before they go to sleep, a reading of a mystery novel or something like that. A more typical thing that people tend to do before they go to sleep. So, history could be an issue, though, if, for instance, the folks in the upstairs lab, the ones where we had actually, we'll make it the folks who had the book reading, they had their heat go out one night. And it didn't go out completely, so it wasn't really noticed, but instead of it keeping a nice 70 degrees, it actually dropped down to like 62 degrees, 64 degrees. It's chilly. And so they were tossing and turning more, and probably just to maintain body temperature, to get the covers closer around them, those kinds of things. So one group had a different effect than the other group because they had different history. An outside influence changed what was going on in the study and created different conditions. Instrumentation could also be an issue in a sleep study. Let's imagine that this same lab, and maybe it's even the same study, but what we have not paid attention to is that the room that had everybody doing the meditation, which we hope to be more effective for better sleep over the night, was used for about 3 months straight, 4 months straight, for a series of studies on some other topic entirely, and that in actuality the sensors under the mattresses were getting old. They had been on a lot, running electricity through them a lot, and they didn't have their connections as good. They had a few things that had broken, and basically they were measuring, I don't know, maybe more erratically, maybe they were measuring lower, but they made it look like possibly that the persons who did meditation were tossing and turning left when actually they were tossing and turning the same amount, but you didn't know it because the sensors were actually no longer calibrated properly, no longer working properly. So you can have an instrumentation effect happen when it happened in one condition or not the other. You've got to be careful of these things. So you always want to check your equipment, check things, and monitor things closely when you have time where things can occur. And this can happen in virtually every study. And all of these threats to validity, I can come up with scenarios to describe where something could happen in one condition but not the other condition. There's also a few threats that can occur for any experiment that you might do. That was the ones we were talking about previously, or they're particularly acute when you have the one group pre-test, post-test design. But most are handled with the addition of a comparison group in those cases. But there are three additional threats that can't be fixed with these kind of structural changes: the observer bias, demand characteristics, and placebo effects. They require some special consideration and some special training and some special management. In fact, that's probably a good way to think about, especially observer bias and demand characteristics, is they're more management problems than they are design problems. Observer bias is when the experimenter interprets observations in favor of the hypothesis. It's a kind of instrumentation effect if you think about it, but it differs in terms of us seeing that there's a motivational aspect. We know why the experimenter is going that direction, or at least we suspect it. And it's not malicious on their part. All of us are going to want to see things more favorably. Heck, I just saw a recent study that showed that the home field advantage is different in American football and hockey and baseball, where it's there but it's relatively low, compared to soccer. In soccer, it's actually very high on home field advantage, and it's presumed to be, it seems to be based upon an analysis, that it's the difference in officials and how much they are influenced, and the fact that there are relatively few officials in soccer. Therefore, one official can have a large effect, and one official is being pressured by a large number of people, rather than a lot of officials who have the kind of, we are a team and we can manage this better. And so that motivational aspect is what I'm getting at here, is the soccer officials aren't there trying to call the game favorably one way or the other. It's just the pressure of 30, 40, 50, 60,000 people, maybe even 100,000 people, telling them they're bums for making a call that the crowd doesn't like. And, well, they're human beings too. It's going to get in their head. Demand characteristics are when the study tips its hand, so that the participants think they know what's going on, rightly or wrongly, and they adjust their behavior. If they think they know what's going on, they may start behaving in a way that is either confirming of the hypothesis or disconfirming of the hypothesis, and it can be a real problem. To fix both observer bias and demand characteristics, we can use what are referred to as double-blind and or masked studies. A double-blind study is when participants don't know what condition of the study they're in, nor do the experiments know it about the participants. The participants come in the study, they're coded in a way, there's a kind of an overseer of the experiment that does know who everybody is in the study, but they in no way interact with the participant past getting them initially recruited and assigned to a condition. All of the interventions that are done, the manipulations that are done, all the observations and measurements and testing that is done, that is all done by persons who don't know what condition the participants are in. And they don't know, and the participants don't know what condition they are in. And these kinds of situations are often used. Mass design, sometimes blind designs or single blind studies, only the experimenters are unaware of the treatment condition of the individual participants. For my dissertation, we had persons either engage in what we refer to as a mock theft. They did what appeared to be a theft, but it was set up for them. They weren't actually stealing anything, but they thought, it sure feels real to them. And of course, they knew if they had actually taken the money or not. But when I was doing the polygraph examinations on them, I was blind. I did not know whether the person was in the stole money and therefore is lying about stealing the money, or did not steal money, therefore is telling the truth about not stealing the money condition. I did not know which condition the persons were in. And therefore, I was in a masked design or single blind study kind of situation there, to keep me unaware, to keep me as neutral as possible in my judgments based upon the polygraph system. Placebo effects are when people change simply because they believe they're being treated. Excuse me. Placebo is a fake treatment, such as a fake pill, a fake psychological intervention, a sham surgery. And believe it or not, they do that. To test surgeries, you will sometimes have a group of participants who are actually, they do an incision and then they sew it up. And so they feel like, they have evidence that they had surgery done on them, and other persons are getting a real surgery to see if the surgery has an effect. And there's relatively few situations where that's a good idea, but there are a few situations where it's a good idea. Placebo effect is real, and it's frankly not very well understood. We do know that persons will have improvements in various kinds of physical and psychological problems based upon believing they're being treatment. There's other things that placebo will not have much effect on. You're not going to have much effect on a broken leg simply by acting like you're treating it. You either treat it or you don't. We know that a certain amount of the improvement that we see in many conditions are coming from this placebo effect of people believing they're being treated. So what we really want to know is whether or not our treatment has more effect than the placebo effect that we know is there. So we got to rule out the placebo effect as being responsible for whatever changes we see. And to do that best, we should have 3 conditions in the study. 2 conditions will do a good job for us. Don't get me wrong, two conditions is good. But a third condition gives you a sense of, well, how much placebo effect is going on. So we have a treatment condition, a placebo condition, which is really what a comparison control condition tends to be, and a no treatment or no placebo condition. It has neither of these things going on in it. That's the one that also might be what we have, and we want to make sure we know what is the placebo effect going on. We want to be able to know that maturation, history, and so forth are not just explaining what we're calling the placebo effect in the situation that we're examining. So, how do we go about trusting experiments? I've given you tons and tons and tons of threats. How can you possibly trust this anymore when I keep using the word threat and there's all these things that can get in the way? Well, because we look at the designs. We see the research reports, we read them, and we see the experimenter did things that ruled out the problems. As a good reader of research, we know the issues that can come up. And we look at what they did, and we can say, no, we don't have to worry about that. No, we don't have to worry about that. No, we don't have to worry about that. We are skeptical. We do ask the questions in our heads as we read. But it's very important that we don't assume bad intent on the part of the experimenter. If we start from a presumption of bad intent on the part of the experimenter, well, they could just be lying in their report and they didn't do anything that they said. And so you have to assume that what they're reporting is their best representation of what they actually did. If you start from a position that they are bad actors in the first place, then you probably should just stop reading, because you can't trust anything that's written there either. Now, that's not to say fraud doesn't happen. Fraud does happen. It does happen. And it eventually is caught, we think, most of the time. And there does appear to be a rise in research fraud going on. So we're unclear about exactly what's going on there, but it appears to be due to increased competition for a reduced pot of research funding that's available out there. If we do find problems, again, we do not assume bad intent on the part of the experimenter. We assume they're just mistakes, or the level best effort and some things couldn't be handled. We do not assume it was fraudulent in an attempt to deceive people. And one of the best ways to see that is by looking in the discussion section of the paper, where they talk about what are the limitations, what could they not do things about. The last portion of the chapter is about null effects. Now, all the preceding were about issues of concern that we might have when we observe an outcome that shows effectiveness of a manipulation or treatment. What about when there's no effectiveness, when the treatment doesn't look like it worked, when it was not successful? We term that a null effect. Null meaning nothing there. Now, this covers a large portion of the chapter, pages 323 through 338. And I think it's overly detailed for what we want to get into in this class. So I'm going to shorten it up a lot. I don't want you to, If you want to read this and learn more about it, I encourage you to do so. Definitely, it's interesting material and it's really well presented. But the fact of the matter is, from my perspective, for our goals for this class, it's a little bit of a bridge too far. But I want us to address it. So I want you to pay attention to what I talk about here in this presentation. That's what's possibly going to be testable. I don't usually say much about what's going to be or not be on my tests, but I'm not going to get into nitty-gritty details out of this portion of the book because I think, again, it's a little bit much. There are several reasons why we might not see a difference between the conditions after a manipulation. One, there's an insufficient difference measured between the conditions. Now, this can happen for a variety of reasons. Your book goes into a great deal of detail about it. I'm just going to mention a couple of these things. It could be the manipulation was kind of weak and didn't really create the opportunity for a difference to be measured. It could be that the measures you use, your dependent variable measures, are insensitive. They aren't likely to detect anything. They don't move much based upon the person's wanting to give you different information because they are very different. But the measurement system doesn't deal very well. These are often categorical type measurement systems. Observational systems can suffer from that as well. You could have what are called ceiling and floor effects. We've talked about this a little bit when we were in our measurement chapter earlier. If you're close to the top end, it's hard for there to be any room for anything to move. If you're doing manipulation, same thing if you're down at the bottom end. So all these things can be an issue. This can happen both with top end and bottom end of an independent variable, ceiling and floor effect for an independent variable, and ceiling and floor effects for a dependent variable. Now, using manipulation checks is very helpful for detecting whether or not you actually have an effective manipulation. You can also have design confounds acting in reverse. That means that the thing that we might think makes it look like something did happen is actually happening in the control condition, and it masks the effect that you're having by mimicking it. You can also have too much variability in your measures. Now, what we mean by that is we're only going to see a difference between our conditions if the difference is big compared to the amount of variation that's naturally occurring. If there is a lot of variability in the measures, then that difference may be obscured by it. Sometimes it can be due to the fact that there's lots of excess error in the measurement, as we were talking about earlier with random error. It could be that there's a great deal more noise in the environment and uncontrolled influences on people, causing them to have a lot of variety. They're randomly distributed, but just they're moving all over the place. And it could be that the measurement system is just not very precise. It's not actually very reliable. Having a very reliable measurement system tends to decrease this variability issue. And third is, maybe there's nothing there to be found. Maybe we're looking, but we've got the wrong idea, that our theoretical application here is off base, and we should not be looking at this. In which case, move on to another project. There's lots of projects. There's lots of questions to be answered. So move on. So what's our take-home message here? This book's perspective is we have an obligation to interrogate the research. And overall, I like it that Dr. Morling wants to take the perspective of interrogate the research. But it's easy to get caught up in an interrogation and turn it into a witch hunt. And we aren't just trying to find things that are wrong just because it makes us feel proud to find things that are wrong, because wrong things are everywhere. We got to find them. They're everywhere. Because they're really not everywhere. People are acting in good faith generally. What we do want to do is find the problems that are really there. So we assume that all researchers start with an open mind and a skilled attempt to craft a study that eliminates the various threats we've talked about. By interrogate, we mean that we want to verify. We want to look for where these things are happening. Make sure that it looks like we got a clean study. So we examine the reports and we read the procedure sections to see how did they collect the data? Did they eliminate these concerns? Can I trust what they're saying about their data is a valid statement to make? We're moving on to Chapter 12 next. See ya.